Hello! Today we will talk about environmental pollution. To put it simply, pollution of the environment is the entry into the environment of the substance harmful to the health of humans, animals, and plants. We can also say that pollution is the entry into the natural environment of any solid, liquid, and gaseous substance, microorganisms, or energies in quantities harmful to the health of humans, animals, the state of plants, and ecosystems. What types of air pollution are there? Atmospheric pollution can be natural and anthropogenic. Anthropogenic sources of air pollution cause, as a result of industrial activity, enterprises release harmful gaseous substances and solid particles into the air. Thermal power plants are one of the main sources of pollution. They emit large amounts of carbon dioxide and carbon monoxide, heavy metals, and particles of unburnt fuel into the atmosphere. The extraction of various types of mineral and energy resources also causes air pollution. As a result of agricultural activities, methane emissions from cattle lead to an increase in the greenhouse effect, and pesticide poison the soil and water. Carbon monoxide is a toxic substance without color or smell. It is formed as a result of incomplete combustion of coal, gas, oil, and other types of fossil fuels. Carbon dioxide is a colorless gas with a smell. It is one of the sources of the greenhouse effect. Ozone is a toxic substance with a sharp specific smell. It is a strong oxidizer. Lead is a heavy metal. Lead enters the air with emissions from chemical production. Hydrocarbons are organic compounds consisting of various combinations of carbon and hydrogen. They enter the atmosphere from unburned gasoline and as a byproduct of the chemical industry. Pollution of water bodies is understood as a reduction in their biospheric functions and ecological significance as a result of the entry of harmful substances into them. Water pollution manifests itself in changes in physical and organoleptic properties, increased content of sulfides, chlorides, nitrates, toxic heavy metals, reduction of oxygen dissolved in water, appearance of radioactive elements, pathogenic bacteria, and other pollutants. The main types of anthropogenic impact on soil are the following: erosion, wind and water, pollution, then secondary salinization and swamping. Also, desertification and alienation of land for industrial and municipal construction. The main directions of engineering environmental protection from pollution and other types of anthropogenic impacts are the introduction of resource-saving, waste-free and low-waste technologies, biotechnology, waste recycling, and detoxification, and most importantly, the greening of the food production, which will ensure the inclusion of all types of interaction with the environment in the natural cycles of the circulation of substance. Radiation technologies are technologies based on the use of ionizing radiation. Today, radiation technologies have become an integral part of our daily lives. At present, research and technological developments in this field of environmental protection of radiation technology are carried out in the following main areas: radiation treatment of natural water, radiation purification of domestic, industrial, and agricultural wastewater, radiation purification of exhaust gases, radiation treatment of solid waste. For radiation treatment of various objects, installations with the following types of ionizing radiation are used. Electron radiation with an energy of no more than 10 megaelectron-volt. Gamma radiation of radioisotope cobalt-60. Gamma radiation of the radioisotope cesium-137. Bremsstrahlung, X-ray generated by electron accelerators with an energy of no more than 5 megaelectron-volt. The choice of the upper energy limit for electrons and X-rays is due to the fact that at the specified energies, induced radioactivity doesn't appear. The energy of gamma radiation cannot be higher than 5 megaelectron-volt, since the radiation occurs when the excited nucleus returns to a lower energy state. All types of radiation have certain advantages and disadvantages. However, at present, the most widely used are gamma radiation of cobalt-60 and electron radiation. Natural water used for public water supply often contains harmful impurities, pathogenic microorganisms, and parasites. A radiation dose of about 1 kg is sufficient to destroy many microorganisms, decompose organic compounds that cause unpleasant odor, color, and turbidity of water. This method is effective against a wide range of pollutants, including toxic and carcinogenic substances. Particular attention is paid to chlorinide-containing organic compounds that enter water bodies both from industrial waste and are formed as a result of water chlorination used for disinfection. Radiation effectively destroys the structure of these molecules into simpler, less toxic compounds such as carbon dioxide and water. Radiolysis of chlorinated aromatic compounds are a promising method for water purification from persistent organic pollutants. Is not without its drawbacks. The dechlorination process, although it removes chlorine from the molecule, is often accompanied by the formation of other potentially toxic byproducts. For example, the radiolytic decomposition of chlorobenzene, a common pollutant, produces phenols, toxic compounds that in themselves pose a danger to the environment and human health. An interesting aspect is the synergistic effect observed when combining radiation with other purification methods, such as ozonation. Moreover, the combined use of radiolysis and ozonation has the additional advantage of providing long-term protection against recontamination of water by microorganisms and parasites. Domestic wastewater can be used for technical purposes after biological and their radiation treatment. For radiation treatment of domestic wastewater after its biological treatment, doses of 0.4 kg to several kg are required. Radiation-treated domestic wastewater is recommended for technical purposes. Industrial wastewater differs from contaminated natural water by the variety of impurities and their significantly high concentrations. Large doses, tens of kilograms and more, are required to purify such wastewater. As a result, combined purification methods are being developed in which radiation treatment is used in combination with conventional methods such as chemical, biological, thermal, etc. When using combined method, a synergetic effect is often observed. Nowadays, electron accelerators are increasingly used for radiation treatment of wastewater. To see this, let us focus on several factors that mainly determine the cost-effectiveness of accelerated electron wastewater treatment process. High power, which allows for large volumes of water to be treated daily, and efficiency. Taking into account some practical aspects, it should be noted that accelerated electron treatment is best used as pre-treatment step before biological and physical-chemical treatment. Under such conditions, a dose of 2 kg allows for the successful destruction of the most organic pollutants. At the same time, wastewater disinfection is achieved. When only disinfection is required, the dose can be reduced to 0.2 kg. When wastewater is left to settle, sediments are formed, consisting of insoluble solid particles 5 to 8% and water 92 to 98%. During biological treatment, another type of sediment called excess activated sludge is formed at the aeration stage. A significant portion of it is made up of microorganisms. The sediments can be used as fertilizers and additives to animal feed. However, they contain microorganisms, parasites, and toxic substances, which is why they must be disinfected and rendered harmless. However, heavy metals remain in industrial wastewater sediments, both irradiated and non-irradiated. In this case, they cannot be used as fertilizers. Interest in the area of radiation technology remains and, in all likelihood, will remain in a number of countries with agricultural areas where the problem of heavy metals is absent. Many countries have accumulated a relatively large amount of waste transformer and hydraulic oils contaminated with toxic polychlorinated biphenyls. Polychlorinated biphenyls are non-radioactive industrial waste from nuclear power plants and are included in the list of persistent organic pollutants specified by the Stockholm Convention in 2001. Today, the simplest and cheapest method of persistent organic pollutants disposal is simple burial. However, using the capacity of the nuclear power plant itself or the capabilities of other organizations that own radiation facility, such as gamma radiation, accelerated electrons, part of the non-radioactive industrial waste can be disposed of. Studies have been conducted on radiation treatment of soil contaminated with chlorinated hydrocarbons and dioxide, polychlorinated biphenyls, and polycyclic aromatic hydrocarbons. Positive results have been obtained. However, in most cases, the doses required for purification are very high. Some of the main air pollutants are sulfur dioxide and nitrogen oxides. Radiation treatment of gases containing sulfur dioxide and nitrogen oxide allows for their simultaneous removal. Research began in Japan, and the results showed that adding ammonia to the irradiated gas results in the formation of a powder product, which is a mixture of ammonium sulfate and ammonium nitrate, which can be used as agricultural fertilizer. This process is now called the Imbara process, named after the Japanese company Imbara, which built and commissioned the first gas cleaning plant. This concludes my lecture. Thank you for your attention.